The topic given to our group is transducer to measure vertical displacement measurement of a vehicle body in vehicle suspension system. Introduction. We are choosing LD300 series AC LVDT. The AC LVDT series are high specification contactless linear sensors which are designed and manufactured to quality standards required for high performance industrial and automotive control and measurement systems. The LD300 series provides our longest stroke length up to ±300 mm or ±12 inches in accordance with the linear variable differential transformer principle. These AC LVDTs are highly accurate. Special winding techniques ensure excellent linearity. The components are then packed in a rugged housing and the transformer core is fitted with an extension rod and very low friction nylon bearings that act as guards. The transducer features a spring return armature. With their long life, infinite resolution versatility, and excellent repeatability, these units are suitable for demanding industrial and automotive applications. Characteristics. This transducer is a passive transducer. These transducers need an external source of power for their operation, so they are not self-generating type transducers. In this case, AC current is used as external source. The transducer is contact transducer. LVDT responds to some input variables such as force and torque, so it's a contact transducer because it measures the input variable through some form of physical contact. Next, it is an analog transducer. These transducers convert the input quantity into an analog output which is a continuous function of time. AC LVDT is a secondary transducer. It is an electrical device that converts mechanical signal into corresponding electrical signal. The magnitude of output signal depends on the input mechanical signal. The transducer is an input transducer. It is an electromechanical sensor used to convert mechanical motion or vibrations, specifically rectilinear motion, into a variable electrical current. This transducer is an inductive transducer that uses the principle of electromagnetic induction to detect or measure objects. An inductor develops a magnetic field when a current flows through it. Alternatively, a current will flow through a circuit containing an inductor when the magnetic field through it changes.
Assalamualaikum semua. Sekarang saya akan menerangkan 3 karakteristik yang terdapat dalam model ni, iaitu operational karakteristik, static karakteristik dengan dynamic karakteristik. Saya akan menerangkan operational karakteristik dulu. Sebentar ya. Pertama kali range. Range ni dalam spek yang telah ditunjukkan, dia paling tinggi, range dia ialah sampai 300 mm ataupun 12 inci. Seterusnya ialah span. Span untuk model ni ialah most robust reliable sensor available on the market and long term associated with a visually infinite lifespan. Maksudnya lifespan dia sangatlah lama. Seterusnya sensitivity. Dalam spek yang ditunjukkan dalam data model ini, menunjukkan sensitivity dia bila range dia decrease, sensitivity dia increase. Solution untuk model ni ialah solusinya ialah infinite resolution. Di sini disebabkan ialah device ni relies on the coupling of magnetic flux. Dan lagi satu, dead band. Dia tak ada dead band kerana kerana input dia, bila input dia berubah, output dia pun akan berubah. Seterusnya ialah static karakteristik. Static karakteristik ni ialah first kali ialah error. Dalam model ni menunjukkan dia ada error yang sangat rendah, iaitu 0.5% full scaling. Sebenarnya dia mempunyai excellent repeatability. Disebabkan dia mempunyai excellent repeatability ni, dia menyebabkan dia mempunyai low hysteresis. Okey, kan lagi satu sebabkan dia mempunyai low error yang sangat rendah. So precision dan accuracy dia sangatlah tepat bacaannya. Okey, seterusnya linearity. Okey, kat sini menunjukkan dia punya proportionally linear LVDT respond to code replacement. Maksudnya antara voltage ni sini linear dengan code replacement. Maksudnya sini bila replacement dia positif, dia mempunyai positif yang increase, dan bila dia replacement dia negatif, dia akan mempunyai negatif yang increase. Dan kat sini menunjukkan voltage ini bila dia vary, kita boleh varykan voltage dia untuk mendapatkan replacement ini. Terusnya dynamic characteristic. Okey, seterusnya zero order measuring device. Okey, kat sini kenapa kat sini saya mengatakan yang bahawa model ini ialah dikategorikan sebagai zero order measuring device kerana dia menghasilkan output yang proportional dengan input dia. Okay, seperti ayat yang kedua, dia kat situ LVDT closely models an ideal zero order replacement sensor structure at low frequency where the output is a direct and linear function of the input. So yang kat sini bila dekat low yang frekuensi, sangat frekuensi dia sangat tepat, dan juga output dia ialah sangatlah direct dan linear. Seperti yang kita tengok kat graf linearity tadi adalah sangat linear dengan dia punya input. Okey, seterusnya ke sini ialah specification yang ditunjukkan dalam data tentang model LD300 series AC LVDT. Kita boleh tengok di sini dia punya core material dia. Yang ni core material kat sini sangatlah nickel dengan ini ialah sangat high permeability. So dia sangatlah bagus dijadikan sebagai core material untuk LVDT ni. Okey, satu ni dia punya untuk electrical connection dia. Okey, kat sini tadi yang mana saya ada bagi tahu bahawa bila range dia tinggi ataupun bila range dia makin rendah, sensitivity dia akan makin tinggi. Okey, kat sini boleh lihat range dia bila dia makin rendah, sini 886 inci ataupun 22 mm, sensitivity dia meningkat sebanyak 34 ohm.
Now let's look into the working principle of the LD300 series. The LD300 series is a type of LVDT transducer. Therefore, it works with the principle of mutual inductance. In a typical LVDT, in general, it has a hollow cylinder, a primary coil connected to an AC source called the primary excitation, two secondary coils connected in series and has equal distances between the primary coil, and a movable magnetically conductive core connected to a push rod that can move back and forth freely, and the output is obtained from the difference of induced voltage between the two secondary coils. So in the first position we have the null position, and in this position the core is located in the dead center of the cylinder. Because it is in the dead center, the amount of induced voltage in both the first and second secondary coils are equal. Therefore, and since the output voltage is equal to the secondary coil, the voltage in the secondary coil minus the voltage in the first secondary coil, and since both of the voltage are of the same amount, therefore the output voltage is equal to 0. So if the core moves a bit to the right, the amount of induced voltage in the second secondary coil will be a little greater than the first secondary coil, since the voltage in the first secondary coil will be reduced. So we have a greater value of voltage in the secondary coil, which will give us a positive amount of output voltage. And if the core moves a bit to the left, there will be more induced voltage in the first secondary coil compared to the second, which will make the voltage in the first secondary coil greater than the second secondary coil, which will give us a negative amount of output voltage. And after the output voltage has been obtained, a signal conditioning is required in the next steps for data acquisition.
A very good day. So this is my part. Jadi as we go through tadi, my group dah sembang which the LD300 series alternating current LVDT have its particularity ataupun specialty dia, such as high spec contactless linear sensors which are sesuai untuk automotive industries, provides a long stroke length, a special winding technique for a sounding linearity, etc. So sekarang to fully understand LVDTs in accordance to its working principle, what you see is the circuit diagram for LVDT. So diagram A. Jadi its build consists of a primary coil. Sini. Okay. Then you can see the two secondary coils ataupun windings, whichever you might call it, over here and over here. Then these coils or windings are wrapped on a cylindrical bobbin ataupun insulated material which are also non-magnetic. Bobbin ni kira yang this lah. So as heads up, both secondary windings have equal number of turns and are placed identically at both sides of the primary winding. Sini. Okay. So the alternating current source are connected to the primary winding ataupun coil. A movable soft iron core is placed inside the insulated form. Yang ni. Okay. Hence, its displacement is to be measured. Is applied to the arm attached to the core. The arm. So, in order to reduce eddy current losses, the rod is slotted longitudinally. Kira macam slide masuk, biasa macam tu lah. The primary windings are excited by alternating current. Hence, it produces alternating magnetic field which induces alternating current voltage in both secondary windings, resulting the differential voltage output across this one. Secondary windings can be measured by voltmeter. Next, I'll pass it to Adi.
Okey, untuk diagram B pula, ada primary dan secondary coil, dan di antara tu ada soft iron core. Dan apabila soft iron core tu bergerak antara dua-dua primary dan secondary coil ni, akan induce flux. Dan daripada situ produce-nya differential output, di mana VO equals V1 tolak V2. Dan daripada voltage, output voltage tu kita akan signal conditioning kan supaya kita boleh baca data dia.
This picture shows the location where an LVDT is usually installed in a vehicle suspension system.